Alright, Algebra, Chapter 6, Section 4, Exponential Functions. Okay, if we look at these two tables, looking at the first one, you see as x increases by 1, what happens to y? Y increases by 1, right? So this is a linear function. Now look at b, as x increases by 1, what's happening with y? From 4 to 8, we could say it increases by 4. But then if it increased by 4, we'd be at 12, not at 16. So actually what's happening is we're multiplying by 2. Okay, so this is not a linear function. When it has a constant factor here, it's being multiplied by the same number every time. We call that an exponential function. We can write that in the form of y equals a times b to the power of x, where a is not 0, b is not 1, and b is greater than 0. So as the independent variable x changes by a constant amount, the dependent variable is multiplied. That's how you know it's an exponential function, multiplied by a constant factor. Alright, if we want to evaluate one of these, pretty easy here, basic. We know that x is 3, so we're going to plug in 3 right there. So it's y is equal to negative 2 times 5 to the third power. So that's negative 2 times 125, and that would be negative 250. And then here, x is negative 2, so we're going to plug that in up here. Y is equal to 3 times 0.5 to the negative second power. Okay, what that means is we have y is equal to 3 times 1 over 0.5 squared. Now, 0.5 is also 1/2, so 1 over 1/2, 1 over 1/2, we can flip that, that is 2. So it's 3 times 2 squared, which is 3 times 4, and that is 12. Alright, if we're graphing exponential functions, I would recommend you go to this website, Desmos.com, and you can test these. You can plug in some functions, and we'll have a look at that here. Okay, so this is the website Desmos, and up here you can type in multiple functions. I could type here y equals 3x plus 2, right? We know that's linear, and then it would graph that for me. And here I've graphed the parent function, which is basically a is 1, so I just have 2 to the x power. I'll write the 1 there so you can see. Now I could change that. See what happens if I change a to 2. Well, the y-intercept moves up to 2. Change a to 3, then the y-intercept moves up to 3. Okay, what if I change this number 2 to 3? Notice this gets steeper. Okay, and so you can investigate, see what that looks like. Now what if I go back to 2 and make this 1, change a, the number in front of the parentheses, to a negative? What do you think would happen? Okay, change it to a negative and it goes down. Okay, it's below the x-axis. Change that back to positive. What if I make b a fraction? So 1/2. Oh, so it flipped it around. Instead of going up from left to right, it's going down from left to right. Because if you square a half, now you have a fourth, right? If you do it to the third power, it's going to get smaller and smaller when you square a fraction. Okay, so I recommend checking that out, and you can see what happens with the graph there. So if we look at this parent function here, the domain, the x values, notice it covers all the values going this way, and it'll keep going, even though it goes up steeper, it'll keep going this way. So the domain is all real numbers. The range, the y values, it never touches the 0. It gets closer and closer to the x-axis, but never touches it. So y is greater than 0. Alright, if I want to graph this, here make note the parent function is y is b to the x power, so a being 1. If I want to graph it, there's a few different ways this graph looks, and we looked at those in the software just now. Okay, so first off, if I have a being 1, and then b is positive, okay, and greater than 1. So that looks like this. Or if a is negative, so less than 0, it'll look like this. So here's an example, -1 times 2 to the x power. And then if we have b between 0 and 1, so like it's a fraction, like a half or a fourth, okay, then it flips around. You should be able to identify those. Again, if a is negative, it'll be flipped upside down, basically mirrored across the x-axis. All right, if we want to graph one of these, and you're not using the website, if you want to try doing it manually, then you'll plug in values for x and make a table. Right? Plug in -2, see what you get. You get 1, plug in -1, plug in 0, makes this 1, so you get 4. Right? And so on. Once you have the table, you'll graph these points and then try to trace a smooth line through those points. So here are those points, and then we'll trace a smooth curve, not line, sorry, a curve through those points, and then determine the domain and range. The domain, x values, it keeps going, it comes from the left, keeps going to the right, so the domain is all real numbers, and the range is again greater than 0. All right, there you have it. That's all for today's lesson. I will see you again next time.